Hello everyone, this is Mr. Molo for lesson 5-3, solving systems of linear equations by elimination. So if you've watched my first two videos, you'll know that elimination is my favorite way to do these problems. I don't know if it's because the problems look complicated, but elimination really isn't that complicated or what. I just kind of like this method the best. So like I said, elimination is going to look more complicated. These problems aren't going to start off looking very nice. Some of you are going to be like, Mr. Molo, why do you like this one the best? These problems look like they stink, but really they're not that bad. Okay, so you're right. If we were to graph this, this wouldn't be very good. None of them say y equals here on number one. If we were to try to do substitution here, none of them say x or y equals, so this isn't very good. But one good thing about this is we're doing elimination. Elimination means to take away. So we're going to look, and we'd like these problems where the x's and the y's are stacked up on top of each other and they equal a number, kind of like how 2 is and 3. All these numbers have the x's on top of the x's and the y's on top of the y's. So we're going to look for ones that are the same, and we're going to do exactly what it sounds like. We're going to eliminate them. Okay, so we see we have 1x here and negative 1x here. So I'm going to eliminate my x's, but I just can't eliminate them. I just can't say poof, they're gone. I need to do some math to eliminate them. So in order to eliminate a positive 1x and a negative 1x, I need to add them together to get 0x. And since this is math, and math is all about being fair and equal, I'm going to add everything in the problem. So I'm going to add 1x and negative 1x, and they're going to cancel out and just get 0x. I'm going to add 3y and 2y, and when I add those together, I get 5y. And then I'm going to add 17 and 8, and I add those together, and I get 25. So now you can already tell we're one step away from solving for our y. So it's 5 times y. I'm going to divide both sides by 5. So I just figured out y equals 5. And I think that was pretty quick. We didn't have to rearrange anything or anything like that. So I like this style the best. And then we need to pick either the top or the bottom, whichever one we think looks easier. I'm going to pick the top one because I don't really like that negative x there. And I'm going to substitute in that 5 for y and see if I can figure out what x is now. So I have x plus 3y equals 17, but we just figured out that y was 5. So instead of 3y, I'm going to put 3 times 5. So now I have x plus 15 equals 17. It's a plus 15, so I'm going to subtract 15 from each side, and I figured out that x equals 2. So now I have a problem where x equals 2 and y equals 5. Okay? Again, I don't think that's as much work as some of the other ones, so this is why I like elimination a lot better. All right, let's look at number 2. This time our x's aren't the same. I have a 2x and a 5x. I can't add those to get 0x. I can't subtract those to get 0x. But my y's are kind of in the same situation as my other one. I have a negative 1y and a positive 1y. Well, if I add those together, then I'm going to get 0y, which is what I want. I want something to eliminate. If you don't get a 0x or a 0y after this first step, then something went wrong. You didn't get something to eliminate. So I have 2x and 5x. That makes 7x. Like we said, negative 1y plus 1y gives us 0y. And then 5 plus 16 is 21. Divide both sides by 7. And we figure out x is 3. So now this time a little different. First one I solve for y first. This one I solve for x first. So now I'm going to take one of those two equations. Again, I'm going to do that bottom one. I don't really like to deal with a negative y. So I'm going to do 5x plus y equals 16. Doesn't matter which one you pick, actually. You could pick whichever one. Some of you are like, oh, but that 16 is way bigger than that 5. That's fine. You can pick the top equation. You'll still get the same answer. So 5 times 3 is 15 plus y equals 16. And then subtract 15 from both sides. So y equals 1. So there are my two answers. Y is 1. And x is 3. Okay, let's do number 3, because now this one isn't a 1x and a 1x like the other one was. Now here I have a positive 2x and a negative 2x, a positive 3y and a negative 2y. So again, I'm going to add this together, because positive 2x plus a negative 2x gives me a 0x, which is what we want. You kind of got to be careful on some of these problems if you have like a negative 2x and a negative 2x, because if we add those together, well, then we get a negative 4x, which is not eliminating anything. So if we end up with two negative numbers, we're going to want to subtract, because negative 2 minus negative 2, that turns into a plus, and that gives us the 0x. So we kind of got to be careful and make sure that we're actually doing the right adding or subtracting for that first step, because that's kind of, well, might mess up the problem the whole way through. All right, so 2 plus negative 2 is 0x. That eliminates. 3 plus a negative 1y gives me 2y, and then 10 plus a negative 2 gives me 8. So I'm going to divide both sides by 2, and I figure out y equals 4. All right, same thing, y is 4, so I'm going to use that top equation. So 2x plus 3y equals 10. And now I figured out y is 4. So instead of 2x plus 3y, I'm going to put a 4 in there. So I have 2x plus, now I have 12 equals 10. Then I'm going to subtract 12 from each side. So 2x equals a negative 2. Divide, divide, x equals a negative 1. So my two answers there, y is 4 and x is negative 1. Okay. 4, 5, 6 look almost exactly the same, except now it's a 3x and a 3y. Same thing. You would add to get them to eliminate. 5x and negative 5x, add to get them to eliminate. Negative 5y, positive 5y, add to get them to eliminate. And then we got some different ones down here. So this one, 2x plus y equals 12, and 3x minus 18 equals y. So this is one where this isn't really set up very nicely. My x is on top of my x, but my y is on top of the number, and then the number's on top of the y. So this is where you'd use, if you have problems like this on the homework, where you would use substitution now, because this problem is set up way nicer for substitution because it already tells us what y equals. Kind of the same thing here. This tells us what 2y equals, so I can divide each side by 2, and I can figure out that y equals 3 plus 2x. And now again, it's already set up in that form to make it say y equals. Okay, so something a little different there. Now you can use some stuff from the last couple days to make the homework a little easier, because it might not always be x on top of x and y on top of y how it is. Okay, looking at number 10 here, it is x on top of x and y on top of y, but they're not the same. I have a 1x and a 2x, and then a 2y and a 1y. Well, I can't eliminate anything. 1 minus 2 isn't 0. So if I have something that's not the same here, what I need to do is multiply one of the equations to make it the same. Okay, so I'm going to end up multiplying this top equation by 2. Everything in the top equation gets multiplied by 2. And the reason for that is when I multiply the top equation by 2, now I have 2 times x, and now my x's are the same. 2 times 2y is 4y, and 2 times 20 is 40. So now if I multiply that top equation by 2, that equation's gone, and now my x's are the same. So I can do elimination like I just did on the previous problem, and now I can subtract to get these to eliminate. I could have multiplied the top or the bottom by 2 as well, and then my y's would have been the same. Again, whichever method you want to do, that's perfectly fine. Okay, so now if I'm going to use elimination here, I have 2x and 2x. Well, now these are both positive here, so I wouldn't add 2x and 2x because that gives me 4x. Okay, this isn't called get 4x, this is called elimination. So I want to eliminate my x's. So now I need to subtract everything. 2x minus 2x is 0x. So everything's going to get subtracted here. So 2x minus 2x is 0x. So that eliminates. Y minus 4y is negative 3y. And then 19 minus 40 is a negative 21. I'm going to divide both sides by negative 3. And I figure out y is 7. Okay, and then same thing, if I just figured out y is 7, I'm going to use that information to figure out what x is now. So I'll use that bottom one there. So I got 2x plus y equals 19, and y is 7. So 2x plus 7 equals 19. Subtract 7 from both sides, so I have 2x equals 12. Divide, divide. So x is 6. So x is 6 and y is 7. Okay. Sometimes, if we look ahead at number 11 here, there's no way for me to multiply 3 to look like 4 or 2 to look like 3. So when you have a problem like this is as hard as it'll get here, you have to end up multiplying both equations, okay? So I'm going to rewrite this on another sheet because this might take up some room here. So I got 3x minus 2y, so this is still number 10. And then I got 4x minus 3y equals negative 4. So we're going to have to find our least common multiple to see what we can turn both either 3x and 4x into or 2y and 3y into. It doesn't matter which one, okay? So I can turn my x's into 12 x's so that they would be the same. So I can multiply the top one by 4 and the bottom one by 3 so that they're both 12s. Or I can change my y's into 6's, and because 2 can go into 6 and 3 can go into 6. So we kind of have a choice here. Since 6 is smaller, I'm going to do that one. So I'm going to multiply this whole top by 3 and this whole bottom by 2. So again, this is going to be as hard as it gets because we need to multiply everything in this problem. So everything in that top equation gets multiplied by 3. So 3 times 3x is 9x. 3 times 2y is 6y. And 3 times negative 2 is negative 6. And then everything in that bottom equation is going to get multiplied by 2. So 2 times 4x is 8x. 2 times 3y is 6y. And 2 times negative 4 is negative 8. Okay? Now my y's are the same. I have a negative 6y and a negative 6y. Okay? And I'm going to subtract to get them to eliminate. Remember, if I add negative 6 plus negative 6, I get negative 12. That's not what I want to do. I wanted to get it to eliminate. So I'm going to subtract everything. 9x minus 8x is just x. Negative 6y minus negative 6y is 0. And then negative 6 minus a negative 8, that turns into a plus plus. And that turns into 2. So I figured out that x is 2. Okay, now I'm going to take that 2 and let's plug it in, let's say, for the bottom one. So instead of 8x minus 6y equals negative 8, I'm going to do 8 times 2 minus 6y equals negative 8. So that's going to give me a 16 minus 6y equals a negative 8. Subtract 16 from both sides since it's a plus 16. And that gives me a negative 24. And then divide. So y equals 4. Okay. And then if I kind of look back at some of these other problems, it's kind of the same thing here. So 9x and 3x. If I were you, I'd multiply this bottom one by 3 so that you both get a 3 times 3 is 9x. Okay, so then you would get 9x minus 30y equals a negative 6. So now 9x and 9x are now the same. Okay, looking ahead at some of these, again, 13 is going to be one where you're going to have to multiply both because 4 times something can't give me 5 unless I want to start multiplying by decimals. 2 times something can't give me 3. So again, we're going to kind of need to look at our least common multiple and be like, oh, I can make both my y's 6y's. If I multiply this whole top one by 2, 4 times 2, 3 times 2, 21 times 2, and the whole bottom by 3, because if we look at our y's now, 2 times 3y is 6y, 2y times 3 is 6y as well. So might have to look ahead at some of those and kind of see some of these problems you're going to have to multiply both on.